Hey everyone, today we are going to do lesson 4.2, which is about step functions. We are not going to be doing this one out of your Springboard book, so instead you'll want the lesson 4.2 guided note sheet that I've posted in Google Classroom. If you have access to a printer, that would be great to have with you. If not, just have it pulled up and you can take your notes in your notebook or on a separate sheet of paper. Okay. Then you'll also need a pen or a pencil and possibly a calculator. Okay. So in this lesson, we are going to graph step functions, and then we're also going to describe the attributes or the key features of these functions. Okay. So first of all, what is a step function? And it says here a step function, or it's also known as a staircase function, is a piecewise function. And so that is what we've been talking about these last couple of days. So it's a type of piecewise function that contains all straight and horizontal pieces. Okay, so straight and horizontal. So as you can see in this example here, um, it does look like a step function, or its other name, a staircase function. It looks like steps. Um, and it is a piecewise function if you look over here, because notice it does have these domain restraints. And then it also has kind of what you're supposed to actually be graphing. So it's set up just like a piecewise function. Okay, so there we go. Let's go ahead and try one. Okay, so first thing, let's go ahead and look at where our fences are going to be. So it looks like we're going to have one fence at -5 and one fence at +2. So I'm going to go ahead and draw that in just like we've been doing at -5 and at +2. Okay, then what we need to do is take a look here, and the first one is where x is less than -5. So I like to kind of think of them as like a left, middle, and right neighborhood or something like that, because we're calling them fences. Okay, so where x is less than -5 is going to be this left neighborhood here. Okay, and that, remember, they are just straight horizontal lines, and this one is going to be at -3. So -1, 2, 3, and it should have a closed, circle because of this less than or equal to. So I know I go down 1, 2, 3, I have a closed circle, and I draw my line to the left. Okay. All right, then the next one is 1. So it's going to be a straight horizontal line at 1. And it's between -5 and 2. So this is in the middle neighborhood. Okay. So that should be here. And on the -5 fence, it should have an open circle. So an open circle here. And on the +2 fence, it should have a closed circle. And again, we did it at 1 because of this here. Okay, and then you would just connect those 2 points. All right, and then the last one is where x is greater than 2, so that's obviously going to be the right neighborhood. So where x is greater than 2, and that is at +7. So we go up to 7, it should have an open circle, and then it should be to the right. So that right there is your step function. Okay. Notice on each fence there are never 2 closed circles. So we have a closed and an open, and a closed and an open. We don't have 2 closed because remember, that would not pass the vertical line test. So that would not be a function, but this right here is a function. Okay. All right, so let's go ahead and move on to another example. And this is more so what you'll see. You'll see different types of word problems, okay? So in this word problem, it says, Alex is ordering a gift for her sister online. The table shows the shipping rates. Write a function and graph the step function. Okay, so first thing we need to do is write our function. So in that last example, the function was given to us, but right now it's not given to us. We need to write this one out, okay? So we have all of our different shipping costs here, okay? Those are actually going to be your Y values or like your inputs. So let's go ahead and put those here. And those are, so if Alex orders something between $0 and $15, she's gonna have a shipping cost of $3.99. If it's $15.01 to $30, $5.99. If it's $30.01 to $50, it's $6.99 for shipping. 50.01 to 75 is $7.99 for shipping. 75.01 to $100 is $8.99 for shipping. And then anything over $100 is $9.99 for shipping. Okay, so that's the first thing you want to do. Then realize this here, these order totals have to be your X because those are your domain restrictions. Okay, so those are the ones that we can write as an inequality, right? So, because from 0 to $15 is going to be $3.99. But now let's think about this. At $15, or sorry, at $0, is she going to have to pay for shipping? No. So we don't want to include that. We just want to do a less than. At $15, we do want to include that. Okay. Now, I know the next one says 15.01, but we're just going to write it as 15. But here's the thing, we are not going to include it because we already included it for the $3.99 shipping, right? So it'd be confusing if we put 15 in both spots and said it was included in both spots. But now we know, okay, if she spends exactly 15, it's going to be $3.99. If she spends greater than 15, it's going to be $5.99 for shipping. And then we know that this is $15 to $30. This next one, again, we're not going to write it as 30.01. We're going to write it as 30, but we're not going to include it. And that's 30 to 50. This next one, $7.99 for shipping, is 50 to 75. Then $8.99 for shipping is 75 to 100. And the last one is anything over 100. So we'll just say when X is greater than 100 because we don't really have a stopping point. Okay. If she spends $200, if she spends $500, her shipping cost is going to be $9.99 from the information we were given. Okay. So your next job is going to be to label all of your axes. So let's label this price with shipping. That's just the name of our graph. You could have labeled that really whatever. Alex's sister's gift, whatever you wanted to do. Online shopping, whatever. But now we need our x-axis to be this order total. That's what we said is the X. That's what we said are the domain restrictions. So that's what we label our X-axis. So order total. Okay, hang on a second, there we go. And then we label our Y with that shipping cost. Then we got to figure out something to count by. And for shipping cost, obviously they all cost something 99. But the highest it goes is $9.99. So I could just count by ones. Or if you really wanted to, you could count by 99 cents. So like 0.99, 199, or count by $1 there. But I'm going to go ahead and say, let's just label this 1 through 10. So 1, 2, 3, 4, 5, we'll just label those. Okay. Whoops. Good thing I went and labeled all of them. There we go. Okay, and then the order total, remember, that's anywhere from 0 to 100. So I'm just going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Perfect. All right, so now let's go ahead and if you wanted to, we could plot each of these fences. So we know we have one at 0. I'm just going to kind of do some dots here. We know we have one at 15. We know we have one at 30. We know we have one at 50. Oops. We know we have one at 75. And 100. Okay, now, do you really need to draw those in? No, you do not, but they're there to help you, okay? So now once we have them, we know $3.99, which is going to be right here under 4, goes from 0 to 15, and it should have an open circle at 0 and a closed circle at 15. I'm kind of just right there under the 4 mark, okay? Then $5.99, so right under 6, goes from 15 to 30, and it should have an open circle at 15 and a closed circle at 30. And then $6.99 goes from 30 to 50, and it should have an open circle at 30 and a closed circle at 50. Whoops. And then $8.99 goes from 75 to 100. Oh wait, no, I skipped $7.99, sorry. $7.99 goes from 50 to 75. $8.99 goes from 75 to 100. And $9.99 goes from 100 on. So that would be your graph, okay? And we have different steps, and we know kind of where each one would fall, okay? All right, now there should be a couple of questions here. So this one is asking, just one question here, asking for the domain using inequality interval and set notation. So my domain, keep in mind, is anywhere from 0 to, I guess, technically infinity here, right? Now, obviously, because it's a word problem, we couldn't really spend infinity dollars. But if you look at your graph, it starts add 0. We can't include 0, but anytime there's a fence, there's a closed and an open circle. So we know that there is a solution for that. So a couple ways we could write this. X is greater than 0, or you could say from 0 to infinity. Now that doesn't make as much sense with the word problem, but that's okay. Then you could also write that 0 comma infinity if you're looking for interval notation, and then set notation x such that x is an element of all real numbers, comma, x is greater than 0. Okay, so that would be your domain. Alrighty, so let's try one more on the next page. And in this one, it says write a function and graph based on the information. So a wholesale t-shirt manufacturer charges the following prices for t-shirt orders. $20 per t-shirt per shirt for orders up to 20 shirts. $15 per shirt for shirt orders up to 21 to 40. $10 per shirt for shirt orders between 41 and 80 shirts, and $5 per shirt for orders over 80. Okay, so again, we need to write our piecewise function. So let's say f of x equals, and these numbers here are going to be our y values, because these numbers here are our restrictions. So those are your x, these are your y. Let's go ahead and write what this should look like. So we've got 20, 15, 10, 5. And then we know that these should be for orders up to 20 shirts. That's when it's $20. So from 0 to 20. But again, if they order 0 shirts, that doesn't make sense that they would pay anything. So it can't equal 0, but it should equal 20. Okay. Then same idea. This next one, I know it says 21 to 40, but we're going to use 20, but we're not going to include it. And then we are going to include 40. And then this one, again, we're going to put 40, but we're not going to include it, to 80, but we are going to include it. And then this one, orders over 80, you could say 80 to infinity, or just when x is greater than 80. Okay, so again, let's go over here and label. So we've got t-shirts. Let's just call that the title of our graph. Then down here on your x-axis should be the number of shirts ordered, okay? Or let's just say number of shirts so I can fit it. And then remember, your y was the price. And you can put price per shirt or just price, either way. Okay, now let's go ahead. We need to get to 20 on the y-axis now this time. So I'm going to count by 2s. Whoa. Yikes, Miss Baumgartner, you went from 10 to 20 all of a sudden. Let's try that again. 10, 12, 14, 16, 18, 20. And then on our x-axis, we have to get to 100, or sorry, to 80 again. So I'm just gonna count by 10s down here. So we know that it gets to 100. All right, cool. So now let's go ahead. So at this one, we are actually starting up at 20. So up at 20, I'm not going to draw in my fences this time. If you find that helps you, you still can. But up at 20 t-shirts, or sorry, $20 per t-shirt, we have an open circle at 0 and a closed circle at 20. And that would be your line right there. Okay. Then the next one is at 15, so that's going to fall in between 14 and 16 here. And that should be an open circle at 20 and a closed circle at 40. Your next one should fall down here at 10, and it should be an open circle at 40 and a closed circle at 80. And then your last one should be down here at 5, so again in between 4 and 6 there. And it should be an open circle and going that way, because anything more than 80 is going to cost $5 per shirt. Okay, cool. So there's your graph. Then there are a couple questions with this one. It says, how much will you pay per shirt if you order 27 shirts? So what you can do here, a couple of things. You can figure out where 27 would be on your graph, so about here. And you can see where that would fall. So see which step it goes to, and that goes to the $15 one. So you could say $15 per shirt. Okay. Or what you could do is figure out which inequality 27 falls under. So is 27 between 0 and 20? No. Is 27 between 20 and 40? Yes. So you would know, okay, it was $15, okay, per shirt. All right. Then this next part is asking you to write your domain. In this case, your domain should be very similar to what we did in the last one. X is greater than 0. 0 to infinity. Or your set notation, X such that X is an element of all real numbers, comma, X is greater than 0. Okay, now range, this is the one that's a little bit different here. And it asks us to write our range using set notation. Okay, so remember, it should start out Y such that Y is an element of all real numbers, comma. Now this one, the range is a little bit weird, because think about this, we're talking about horizontal lines, right? So there's all this space in between, okay? Here and here and here and here. So all you can really say for this is that the range is equal to all of those numbers that were our range, right? So at y equals 20 or y equals 15 or y equals 10 or y equals 5. So I know it's a little strange, but that's really the only place where there are y values, where the y exists. So that is your range. Okay. All right. So this last one, I want you guys to try on your own. It says a parking garage in downtown Chicago costs $10 if you park there for 5 hours or less. If you park there for more than 5 but no more than 10 hours, you are charged $25. If you park more than 10 hours, the fee is $60. So you're going to write and graph up a step function, and then you're going to answer parts B, C, and D. So how much will you pay if you're parked there for 8.5 hours? And then write the domain and range. Okay, so please pause the video here and go ahead and do that. And then hopefully you've paused the video, and here is what your answer should look like. So first, for part A, you have your function and you have your graph. Then for part B, you need to figure out what you would pay if you were parked for 8.5 hours, and you should have gotten $25. Then for parts C and D, you should have written your domain and range. Okay, so check your work there. And tomorrow during our Zoom, we will continue to go over step functions. All right. Thanks. Have a good one.